Today we shall create a model of a building, a typical building, using the STAAD Pro. Now, first of all, we have to draw the plan. So, let us see. Say this is the plan. So, for example, you can consider these things. So there is 4 rooms and different size of the rooms are there. So to draw this plan in the STAAD Pro, you have to use the grid line or grid system. Okay. So first of all, you have to draw a plan and you have to draw you have to set the grid system with the plan. Now, this is the grid system, and you can see for every horizontal line I have taken the grid line. Okay, for every horizontal line, and for every vertical line also I have taken the grid line, so I can measure the grid line distance. So basically, so this is actually the grid system. If you see the grid system separately, so you can see this is the grid system. So this type of grid system you have to create in the STAAD Pro. Okay, that's why you need to know the grid line distance. So then this is the diagram and this is the grid line distance I have already created. So this grid line distance you need to know, you need this data. So let us start. Go to grid, beam grid, go to create option and select the irregular one and type any name. So new building. Now select XZ plane so we can draw the plan. Now you just put the value here in the x direction. So suppose this is our x direction. Okay. So first grid point is the 0 line. This is the 0 line, and this is the line 1.5 meter from the 0 line. So put 0 space 1.5 space 1.3 space 1.2 space 1.5. So those are the relative grid line distance in x direction, and in y direction first of all 0, then space, then this is the first value 1 space 2 space 3 space 1.7. Okay, now click on OK. Now if you check this new irregular bit system, you can see this is the diagram. Now we have to plot the plan in this grid line system. So when you are going to draw the plan here, so you have to be careful. Now you see this room 1.7 by 1.5 meter, this room will be created at this position. Okay, so this is 1.7, this distance is 1.7 and this distance is 1.5. After that, this 3 by 4 room, it will be created at this position. It will be created at this position. So this is 3 and this is 4. So let us start from here. So first of all 1.7, next 3 and next 3 meter. So this is 1.7 meter, this is 3 meter and this is also 3 meter. And the next line would be only the 1.7 meter distance line. So press Ctrl and click here and next click here. Then the third grid line will be for the 3 by 2.7 room. So it will be this line. Yes, it will be this line, and the fourth grid line will be for 3 by 4 room. So this line will be the line for 3 by 4 room. And next the final line will be for 2 by 2.8 meter room size. So this will be the line. Now I have created the beam in Z direction. Now I will create the beam in Y direction. Sorry, beam in X direction. So press Ctrl and click here, and this will be the beam for 1.5 by 1.7 meter room. Next press Ctrl and click here and click the next point and click the another point. Now press Ctrl, click here and click here and yes, this point and this point also. Now okay, I have made a mistake. There should be one node at this point. So okay, no issue. I shall create the node at this point. Now click at this point and at this point to make this room. Okay. So suppose you can see there should be another node at this point so that we can create this beam. So this is my mistake. So what we have to do? We have to create the beam at this point and we have to insert a node also. You can see when I am going to place the cursor on the beam will show the color. The color indicates the first and ending point of the beam. The green line indicates the first point of the beam and the blue line indicates the ending point of the beam. Okay. So at this some position I have to find out the distance where the node will be created. So this node I have missed. So let us try to find out. Okay, this is 2 meter distance. Okay, this is this distance is 2 meter. So from this point to this point will be 2 meter. Now click on add beam. Just don't click on the drop down menu. Click on add beam and click here. So do you want to add a new node here? Yes, I want to add a new node here. Okay. Now the position we have to add the position. So the position will be the total distance of the beam is 3 meter. Total distance of the beam is 3 meter and at 2 meter position the node will be present. So if I put 2 here and add a new point, I think it will be created. So let us see. Okay, yes, it is created and I have to click on the next point of the beam. So click at this point. Okay. So again I am showing these things. So we have to place the beam node at this point so that we can create the beam at this point. So click the add beam option. Click the add beam option. Now click on the beam So click yes. Now place here the distance 2. Okay, so 2 meter from the starting point, that's why I placed 2. Now we have to click add a new point. So this is the new point. Now click OK. Now select the another point of the beam. Okay. Now this is the plan. If you see the top view, you can see the plan. So the orientation is something different, no issue. This is the orientation, but for this case this is the orientation, no issue. So this is our plan, and now I have to create the multi-story building. So to do this, first of all I have to select all those beams using the rubber band method. Now go to geometry, click on this command, that is translational repeat. Click on the translational repeat, select the y direction, because I want to repeat this plan in y direction. Now place here the floor to floor height. Generally the floor to floor height would be 3 meter for a residential building. So floor to floor height will be 3 meter, and number of step will be, suppose I am creating the G plus 6 story building. Okay, G plus 6 story building. So G plus 6 means 7 step will be there, and the ground floor will be for car parking only. So the height may be something less than the 3 meter, you can consider. So this is 2.8 meter length for the ground level. So you have to change the height of the ground level. Now click here, delete, okay, double click it, delete it, and type 2.8. Okay, fine. Now select the link step. Okay, select the link step. So in global y direction should be checked here, and the floor to floor height should be there, and if there is some different height, then also you have to mention here, and please check the link step here. Now click OK. So we have created these things. You can see the isotropic view. So this is the isometric view. Okay, this is the building. Now this beam is called the tie beam at the ground level. This beam is called the tie beam. Okay, so below the tie beam generally we have a column with 1 meter generally. So we have to create the beam of 1 meter here also. Then we shall use the support condition. So at this point, generally at this position we do not provide the footing. Okay, generally we create 1 meter or whatever it is the required length, the column. Then after below this column we generally provide the footing, whatever it is, isometric or as isolated footing it may be, or it may be combined footing, whatever it is. So we have to create the column below this tie beam. Now to do this, first of all we have to select the node. you have to select the node. Okay, so you can select this node one by one. This is not the node cursor, this is bean cursor, that's why the bean is selecting, the node is not selecting. So you can change the cursor here. Yes, this is the node cursor. Okay, this is the node cursor. So you can select the there is some okay, so go to node cursor. I think the node will be selected, but somehow it is not selected. Okay, now the node is selected. Now you have to select the node individually, but it is a laborious job. To select the every node individually, because we have different node at different level, so it may be a confusion, it may create some confusion. So whatever you have to do, you have to go to the front view or side view. Okay, suppose this is the front view. Now if you select the node using this rubber band, then you can see that each node at this level will be selected. So go to isometric view and you can see this is the things. So all nodes are at the same level. Okay, now we go to translational repeat. Go to translational repeat and y direction, and the step should be and the spacing should be -1, because I am creating the 1 meter length. Okay, column. So now click the link step and click OK. You can see 1 meter column is created. Okay, this is our geometry. Now what is the second part? The second part is you have to apply the properties. If you see the 3D modeling we are rendering here, you can see this is only the line. Okay, this is the center line only, center line of the structure. So I have to apply the properties here so that it can be converted to beam and column. So go to properties, click define command, select rectangle. Now put the value YD. Okay, let me do one thing. Utility command file. Yes, this is a command file. You just change here kilonewton and meter. Save, close. Okay. Now go to properties, define rectangle. Now put the value of beam section that is YD, that is it may be 0.5, 500 millimeter depth of the beam, and 0.3, 300 millimeter depth of the width of the beam. So add, you can see, and now again you choose the column section. Say 400 by 400 will be our column section. So add this one. You can see this second reference is for the column section, and the first reference is for the beam section. Now beams are present, beams are lies in XZ plane and at different level. Okay, so along x-axis we have a beam at a different level, along z-axis we have beams at a different level. So go to select, and you can easily select all those beams by some number of click. So go to select, and if you go to geometry, and you can see here this parallel option. You can see 3 planes are there, x, y, y, z. If you click on XZ option, then you have to put the height. Okay, the minimum and maximum y range you have to put, so that software can understand that between this height you have to select the all those member lies in this plane, XZ plane. Okay, so minimum y value is 0 and maximum y value. Now you have to know the maximum y value. Okay, so let us measure the maximum y value here first of all, then I will go to select. Now just press the cancel button and go to utility, go to node tools, and go to node to node distance here. Okay, so this is our node to node distance we can measure using this procedure. Now click at the 0 point, at the 0 reference point, that means the origin of the grid line, and click at the top. Now this is 20.8 meter. Okay, this height is 20.8 meter. Now remove this one by clicking here, remove node to node distance. Okay, fine. So go to select, go to parallel, and click XZ option. So minimum range is y and maximum range is 20.8. Okay, so I am putting 20.9. Okay. Now if you click OK, then you can see all those beams along x axis and along z axis for different level will be have selected. Okay. Now there is another method to select the beam, that is the second method is here select the you press the select option, then go to the beam option and click here parallel to x, click here again. This is the all beams along x axis are selected. Okay, now go to here again, click the parallel to z. Okay, so all those things are selected. So first of all you have to select the section, then you have to select the member. Okay, then you select you have to assign. So I am choosing the assign to selected beam here because I have selected the beam. Okay, so assign to selected beam, click assign button, yes. Now okay, So if you see the properties, this is the okay, there is some problem. Properties is not showing here. Okay, no issue. Now select the column size, the column section, and go to select. Now go to beams directly, because we have only structural member in y direction only. So click here, select the y direction only. Okay. Now still assign to selected beam, assign yes. Okay. Okay, now you have to place the support. Okay, so go to support. So create the support. I am going to create the fixed support. Click on add. Okay. Now you have to provide the support at the below the 1 meter column. Okay, so it will be better if you select the node first of all. So go to front view and take the node cursor. Now select all those nodes here. You can see all nodes are selected, and select the you have to select the support first of all. Okay, like the properties, you have to select the support first of all, then go to top view, front view. Go to front view and select all the nodes. Okay, all nodes are selected, and assign all those the support to the nodes. So assign to selected nodes. Click on assign. Yes. Okay. Now this is our model, and we have created the support, and now go to loading. So in case of loading, just click the load case details, click on add button, and select the dead load. Okay, now dead load, click on add. Next click select the live load. Click on add. Now select the wind load. Click on add. Now select the seismic load. Click on add. Okay, now close it. So now we have to apply the dead load. First of all, the dead load of concrete will be applied. So it is actually the self weight of the beam or column, like that. So select the dead load and click on add, and now you can see there is a term that is self weight. Okay, under the self weight, the load is self weight load, and the direction is, by default it is y direction, because self weight is acting in y direction only, and factor is -1, because minus is because it is a downward force, that's why it is minus. So -1, and y direction by default is present. Now click on add. Just don't do anything, click the add. Okay, Now we have to apply the member load. Select the member load. Now we have to place the uniform force here. Okay, so first of all you have to calculate the uniform force, and next and then you have to apply that one. Okay, after that you have to apply the floor load here. Okay, all those things I will show you one by one, no issue. So now how can we assign this the self weight? Just click the self weight one and click the assign to view. Please keep in mind when you are going to select the assign to view, before that you make sure that you have the total structure in your display. Okay, so it will be better if you click the display whole structure and then after apply the self weight. It will be better. So assign to view, assign, yes. Okay, self weight is assigned. So in the next video I will show you how can we place the dead load one by one and how can we place the live load one by one. Okay.